You are the only That's the problem I've always had. But I don't have to feel like I can study it.
No? No one's here? Wait, do we have class today? Stacy here? I might sit up there. Okay, good. There's other people. Megan and Dana. Nick Curtis, and then like the three of us are. Yeah.
No, we are not. I'm sitting with that three crash doors. That was our last Did you see she
Yeah, that's what I was.
Oh, there's nothing in there.
Oh, there is that?
Besides this.
Yeah, I did.
First time was oh, like shit. Oh, nice. I'm gonna do two. Thank you. And then it's nice to blanket. Did you do courses on it? She did. Okay.
I haven't done
You got
any. Yeah, I should.
she likes
Or not. But
I have a
yeah, nobody agreed.
How?
That was fun. Oh, I've had the thing that you guys said.
Oh, I see.
Oh. Oh, you still have three. I didn't. I got to explain.
For what? And do it. Please get on second. You on second.
Okay, Megan,
Here.
Elsa,
Here.
Morgan,
Here.
Allison, Katie.
She's coming. She said she'll be a couple minutes late.
Okay, thank you.
I know you weren't here, but I wasn't here. Okay. I'll send it back to you.
Leah,
Here.
I'll be back.
Catherine, Curtis,
Here.
Okay, so today's the last class, and our exam will be next Wednesday. Just like before the first two exams, you will come to the classroom. Okay, I guess you probably should take a calculator, non-graphing calculator for those counting problems. If you want to use your phone, I guess it'll be okay. So if you don't have a calculator. Okay, any question about the exam next Wednesday? No? Okay. So today we're going to go over that practice exam. Most of you did okay. I think most of you got like just made a small mistakes here and there. So I will give you the correct solutions here. Elsa, can I share your solutions with everybody?
Sure.
Okay, thank you. Let's look at the first one. So the setup is okay. Some of you made some mistakes in the calculation. I think, let me see. Wait. Okay. Well, then when I enlarge it, it becomes a little big. Anything else I can?
I didn't finish this.
Okay, well. Well, I guess looks like on this computer, I have to open it with this Paint software, but it's when I enlarge it, it becomes very blurry. Okay, so I guess we can switch between the computer and this paper here. Okay, so the first question, everybody has the setup right. So case 1, you were supposed to multiply, so plug it in. But, so when we do this type of question, the first one, the second one, we are using indirect proof. So make sure you tell us indicate very clearly what the contradiction is. So when you say suppose that A is not a multiple of 3, but this is something we want to exclude. We actually want to prove A is a multiple of 3, so you want to exclude this possibility. And so what can exclude that when you get a contradiction? So case 1, when after you plug in A equals 3k plus 1, you will get expression. So you replace A with 3k plus 1. And we already learned the formula, binomial formula. You can use the formula to do this now if you want, or you can just use simple algebra, multiply 3 times. And you should get something like 18k cubed plus 27k squared plus 9k plus 1. I think if you didn't get this, I think almost everybody, I think Elena, you made a mistake in that calculation, so double check on that part. When you get here, do one more step to show why this number is not a multiple of 3. Because you can only factor 3 out of the first 3 terms. So to show a factoring of this step. And there's single number 1. There's no way you can factor 3 out. So that's why this is a multiple of 3 plus 1. It's not a multiple of 3. So when you get in here, add a sentence saying A cubed. Okay, so this is what you say. Then A cubed is not a multiple of 3. Why the problem says clearly A is a multiple of 3. Let me bring up the page. If you look at the question, it says, suppose prove if A cubed is a multiple of 3. So we do know A cubed is a multiple of 3. But now we're saying A cubed is not a multiple of 3. So that's a contradiction. So I would say contrary to the conditional statement that has a hypothesis or condition that A cubed is a multiple of 3. So we're saying A cubed is not a multiple of 3, but we do know A cubed is a multiple of 3. So that's a contradiction. And then the contradiction tells us it's not possible for A not to be a multiple of 3. So that's case 1. Case 2, you would do the same thing. I did put a comment in the feedback section. If you stopped right there, I guess I probably won't deduct any points if you stop there, but it's better to do one more step like Elsa did. Again, it's a little blurry, so I'm going to rewrite it here. So for case 2, after you work everything out, you would get something like this. 18, when you plug 3k plus 2 in here and work out 18k cubed plus 4k squared plus 36k plus 8, many students did this, factor out of 3 from there, and left that 8 there. Well, it's not wrong. You can still say, well, this is 3 times the integer plus 8, which is not a multiple of 3, because you cannot factor 3 out of 8, right? But I think it would be better if you can split 8 as 6 plus 2. So rewrite that 8 there as 6 plus 2. And that 6 is a multiple of 3. So you can factor 3 out of 6, which gives you factor 3 from everything except a 2. So I would have just leave a 2 there. 6k cubed plus 18k squared plus 12k plus a 3. So that 3 comes from the 6. So 8, again, like I said, I won't mark you wrong. And I won't deduct any points if you didn't do that. If you say, well, 8 is not a multiple of 3. That's why 3 times something plus 8 is not a multiple of 3. If you do explain that, it's fine. Or you can fact out, give what outside some other students did. Fact, split 8 as 6 plus 2. So you can factor 3 out of 6 and leave your 2. So this is the integer 3, a multiple of 3 plus 2. Because we know any integer, it's either 3 multiple of 3, or multiple of 3 plus 1, or multiple of 3 plus 2. There are only 3 types, right? So it would be easier for us to determine, okay, that's not a multiple of 3, it's a multiple of 3 plus 2. So again, at the same sentence, say this is not a multiple of 3, contrary to the condition that a cubed should be a multiple of 3. So these two contradictions tell us our assumption A is not a multiple of 3 is wrong. This cannot be happening. If this is true, then I will get 2 contradictions. Okay, so that's the first question. Just a few words on there. Any question about this one? The second one, I think pretty much everybody got it right. Just say it when you write on a proof, it's like you are writing down an argument, explaining something to somebody. So make sure it's readable, it's clear. Everything you write down, it makes sense. Or you believe everybody, if you're trying to explain this to somebody else, they will understand you. So when you do the second question, again, indirect proof, suppose it is rational, and I'll skip all of that. When you get here, so square root of 3 equals a over b, and make sure you put down the greatest common divisor is equal to 1. So later, the contradiction will be, it's cubed, right? So the contradiction will be this. Okay, so we will contradict that. And when you take the third power, you get a cubed b cubed. The reason we're doing all this algebra work is because we don't see any contradiction yet. So you have to keep going until you can see some kind of a contradiction. And we can multiply, get rid of fractions. So this is an equation that can tell us a cubed is a multiple of 3, is a multiple of 3. That's the definition of divisibility. If you can write something as 3 times the integer, that means that that number is a multiple of 3. And by number 1, so I do need a more explanation. If you don't say anything, technically if you just say, okay, therefore, so a is a multiple of 3, this is fine. Where does this come from? If somebody asks you, how did you know if a cubed is a multiple of 3, then a is a multiple of 3, that's the problem. We just proved it, number 1. You can say by number 1, we proved. Okay, so that's why I put the question right about that, so you will see. You can explain it easily. Okay, so if you know a is a multiple of 3, you can write a as 3k. K has not been used, so we plug 3k back into that equation. So 3b cubed equals 3k cubed, and simplify it using algebra. 3 cubed is 27, k cubed is k cubed. And divide both sides by 3. So you are going to get b cubed equals 9k cubed. But 9k cubed, apparently it's 3 times 3k cubed. So that tells us b cubed is a multiple of 3. If b cubed is a multiple of 3, by number 1 again, b has to be a multiple of 3. So you do need to give me all that detailed explanation. So instead of just saying, okay, a is a multiple of 3, b is a multiple of 3, and you do need to explain that. How do you know a is a multiple of 3? Well, because a cubed is a multiple of 3. How do you know a cubed is a multiple of 3? Because a cubed equals 3 times b cubed, 3 times the integer. So the same thing here, the same explanation for why b is a multiple of 3. When you get both numbers are multiple of 3, it's like a is a multiple of 3, b is a multiple of 3, which means a and b have 3 in common, which contradicts that they are relatively prime. They don't have anything in common. Okay, so the last sentence should always be there's a contradiction. And if you want to stop right there, say there's a contradiction, we know, okay, whenever you get contradiction, you are done. You want to say one more sentence, say, therefore, cube root of 3 is irrational. You can. If you don't say that, it's fine. But anytime you use indirect proof, specify clearly what the contradiction is. Or say very clearly these two statements are contrary to each other. Which two statements? Previously, the two statements that are contrary to each other is A is not a multiple of 3. That's the assumption for indirect proof. But in the problem, there's a condition which says A cubed is a multiple of 3. That's why these two sentences are contrary to each other. Just like in real life, if you tell somebody it is going to rain today, and it is not going to rain today, that's contrary to each other. So that will tell you that that's impossible, right? So if this one of these have to be wrong. So if A cubed has to be a multiple of 3, then your assumption is wrong. That tells you A has to be a multiple of 3. Similarly, in this case, our contradiction is A and B don't have anything in common except 1, but then you find out A and B have a common number 3. That's the contradiction. Okay, so the first two is reviewing indirect proof. Because direct proof, I think, from the first exam and second exam, I think almost everybody got the idea how to do that, so I did not really put any questions on the final. Okay, number 3. I think there's only maybe 1 or 2 students who didn't do this right. Everybody got it right. So the number 3 and number 4 are mathematical induction. So first of all, you have to let m be equal to 1 and plug in there. So let me go over the mathematical induction process. Mathematical induction, first step, you always do the basis step. You plug whatever the smallest number is. In this case, n equals 1. So you plug it in, you get 13 to the first minus 1 is divisible by 4. That can be proved very easily because 13 to the first minus 1 equals 12. And we know 12 is divisible by 4. You don't have to even prove it because it's very clear. The inductive step, by the way, in mathematical induction, always have 2 steps. Basis step, inductive step. You must show both. So inductive step, you will replace that m with k. So I change n to k. And change n to k plus 1. You will get 13 to the k plus 1 is divisible by 4. So pretty much means if you can factor 4 out of 13 to the k minus 1, you will be able to factor 4 out of 13 to the k plus 1 minus 1. Well, that's the algebra work here. So if 13 to the k minus 1, you can factor 4 out of there. You can write it down as 4 times m or 4 times l. And then that will tell us 13 to the k equals 4m plus 1. You add 1 to both sides. And why did I solve for 13 to the k? Because we need to factor a 4 out of here. And we know 13 to the, by algebra formula, 13 to k plus 1 minus 1 is equal to 13 times 13 to the k. K plus 1, where does k plus 1 come from? It's 1 plus k. That's our algebra formula. So now we can replace that 13 to the k right here with 4m plus 1. So we're going to get 4m plus 1 minus 1. And multiply out to use algebra, we are going to get, I guess we can even leave that 4 there because later we are going to factor the 4 out. So 13 minus 1, which gives us a 12. That's a 12. Apparently, it's divisible by 4, and that is divisible by 4. So let's factor out a 4 from both of them. So look, how did I factor a 4 out of this expression? Well, I replaced 13 to the k, and use algebra, we can factor 4 out. So then you will be down there. So that's number 3. Now, number 4. And so I gave an explanation on Monday, but again, still the how we arrange the argument. So I'm gonna write down the explanation here. I think I can skip the basis step, right? So when you do the basis, we just replace m with 1 in this case. Well, I guess I can go ahead and do that. So when n equals 1, you get 5 times 1 plus 1 less than or equal to 6 to the first. Apparently it's true, because 5 plus 1 is 6. 6 is less than or equal to 6. The inductive step. So for many of you, I put a comment in the feedback. I said rearrange the argument. So like I said, the way you write, it has to make sense. You cannot write down something that comes from like the conclusion. For example, when you go to the court, you want to prove I am innocent. Before you prove it, you cannot say anything. You cannot start with the sentence argument with that. So before you prove anything, you cannot assume it is true. So for example, when after you write down, in this case, 5k plus 1 less than or equal to 6k, this is true. You assume this to be true. But you want to prove 5 times k plus 1 less than or equal to 6k plus 1. So this one, before you prove it, you don't know whether it's true or not. So I'll put a question mark there. And so it's better not to start with that proof. Start with this and go down, okay? Because you don't know if 5 times k plus 1 is smaller than or equal to 6k plus 1. So let's try not to start the proof with that statement. There is a way to do that, but you have to add some sentences. You will have to say, in order to prove 5 times k plus 1 is less than or equal to 6k plus 1, I need to prove something else. So if you want to start with this, you have to add some explanation there. Otherwise, it will be confusing. So this is the way we're going to do. But we do know this is true. 5k plus 1 is smaller than 6 to the k. So I'm going to add 5 to both sides. I explained this on Monday, why we add 5 to both sides, because we want to match the left-hand side. So you're going to get 5k plus 5 plus 1 less than or equal to 6 to the k plus 5. And that part right there, if I factor a 5 out of the first two, that gives us exactly the left-hand side needed. Well, because I got the idea from here. I worked this out. I realized I need to add a 5. So when you get here, every step has an explanation. So for example, if you ask me why this is true, because it's the inductive assumption. And why is this one true? Because I added a 5 to both sides. And then why is this true? Because I factored 5 out of the first two. Now the next step would be this would be less than or equal to 6 to the k plus 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 6 to the k. 1, 2, 3, 4, 5. Need one more. Plus 6 to the k. And if you ask me why is this one true? Well, because 5 is smaller than 6 to the k. Right? Okay. What's 6 to the k? Can everybody understand why 5 is smaller than 6 to the k? What kind of number would be 6 to the k? If k is 1, what do you get? 6, right? Apparently 5 is less than 6. If k is 2, you're going to get 6 squared, which is 36. Even bigger. If k is 3, 6 to the third, which is 216. So it's just going to, this number, the smallest number for 6 to the k, the smallest will be just the 6. If the smallest is bigger than 5, of course, for any k, it's going to be bigger than 5. In other words, 5 is always going to be smaller than 6 to the k, right? Okay, so if 5 is smaller than 6 to the k, compare those numbers here. 6 to the k plus 5 is definitely going to be smaller than, you are adding a bunch of 6 to the k. So these two are the same, are equal, they match. And the second number is already smaller than the second number. Not to mention, we still have a bunch of numbers we're adding, right? So when you get it here, you can continue to say, well, what's 6 to the k plus 6 to the k plus 6 to the k 6 times? That is the definition of multiplication. That is equal to 6 to the k times 6. Because if you add something 6 times, which means 6 to the k times 6. And what's 6 to the k times 6 by algebra formula is 6 to the k plus 1. So we're done there. So that's how you're supposed to write down the argument. Every step is either, and I guess it's mainly algebra. Every step follows either a formula from algebra, a definition of multiplication, or a property of inequality. Well, you can, if you have any, yes.
How did you get from like 6 to the k plus 5 to like 6 to the k to 6 to the k to 6 to the so on?
Okay, it's because, how did I know I should do all of that?
Yeah.
Because,
Well, like, did you just go from like 6 to the k plus 5 to like all of those?
yes, okay.
So wouldn't it be plus 5, 6 to the k though?
5 plus 6 to the k. Wait, hold on a second. So let me first ask you, do you agree this number is smaller than this?
Yeah, absolutely.
Okay, so
Okay.
1, 2, 3, 4, 5.
So you just put it in? Oh. Okay.
That's right.
I see. All right.
Okay.
Great. Yes, this makes sense. I thought that somehow with algebra you got 6 to the k plus 5 to all of that. And I'm like, so but yeah, I'm good.
All right. So this is like, I mean, if you ask me, how did you know you should do that? It's because I want to, my final goal is to get to what? I need to get to 6 to k plus 1, right? If I put 6 copies of that, that would give me 6 to the k times 6, right? And exactly 6 to the k times 6 will be the same as 6 to the k plus 1.
Yeah.
Okay. So the inequality part, it looks like the problem with proving inequality is a little confusing right here because you don't need to prove that they are matching. We do use this kind of idea in real life. You may not realize it. So, for example, if I tell you potato, a potato is, I was like a potato. Is this potato? Is that how you spell it? Potato. So I was reading my first grade daughter's homework, and on Monday, so after Monday's class, I was reading my daughter's homework. She's in first grade, and there's a question like this. That resembles what we're talking about. So I realized we do use this a lot. So the question says the length of the potato is shorter than carrot, and then it says the second sentence says a carrot is shorter than, say, maybe a celery, and they ask you a question: is potato shorter than celery, or is potato longer than celery? It's like a transitive property, right? So even the first grader knows that, okay, the potato should be shorter than celery, right? Okay, but what are we doing here? We are doing, so this is what, if you look at the problem, it's very similar to this concept right here. So what do we know? We know 5 times k plus 1 from here. After we add 5 to both sides, we're going to get something like this. So you can think of this as our potato. And this is it's a carrot. So we already know potato is shorter than carrot. But what do we need to prove? The one we need to prove is potato is shorter than 60k plus 1. So that is our potato. You want to prove the potato is shorter than, it's a different one. It's not a carrot, it's celery. So how would you play, if you already know, say I'm telling you, suppose you've never seen potato, carrot, or celery before. If I tell you potato is shorter than carrot, I want you to prove potato is shorter than celery. All you need is what? To prove carrot is shorter than celery, right? If carrot is shorter than celery, of course, the even shorter one, potato, is going to be shorter than celery, right? So that's the idea behind that. It's like transitive property, so carrot is longer than potato. If you can prove the longer one, carrot is even shorter than celery. Of course, the shorter one, potato, is going to be shorter than celery, right? So that's why I had to prove the carrot is shorter than celery. If carrot is shorter than celery,
why can't you just multiply it both sides by 6?
That's another way, but you're not going to get it directly either. Okay, you still have to do that work. So whenever you do inequality or this type of proof, you either try to match the left side or you need to match the right side, right? So if you multiply both sides by 6, there is a problem you still have to work it out. So, but I think I give you. If you did that, I put a comment in the feedback. So say, why don't we multiply by 6? If you multiply by 6, yes, you are going to get 6 to the k plus 1 immediately. But the problem is, don't forget, you cannot just multiply 6 with 1. You have to multiply 6 with the 5k, right? So that's going to change that to 30k plus 6. Yeah, you can still continue to work this out. How would you finish this? You will have to prove what? In your case, you will have to show.
Can't you just take out the 5? So could you do like
5k plus 1 is. So what do we know right now? We know you want to prove what? You want to prove 5k plus 6 is less than this number, right?
Yeah.
That's what we need to prove. But you already know through 30k plus 6 is less than that. So what's left to do? As long as you show what? So this is like as long as you show what? 5k plus 6 is smaller than 30k plus 6. If you show that, yes, that will work. That will work. Okay. So that's a different way. But the idea is the same though. So either match the left or match the right. So in this way, you may think it's a little easier, right? I think probably it's going to be a little easier because 5k is going to be smaller than 30k, right? So which means 5k plus 6 is going to be smaller than that. So it's kind of like telling you, so this is what you're doing. It's a different way. If you add this statement, so look at statement 1 to statement 2. Can we get that? Can we get this? So this is like potato shorter than carrot, shorter than celery, then potato is shorter than celery, right? Yeah. So it's a different approach. That will work.
Okay. I did that in my thing. That's why I was asking about it.
Yeah, I think you forgot to distribute that 6 to the 5k, right?
I did.
And then,
yes.
So so you get 30k, but how do you get rid of the 30k, put a 5k there? You just show 5k is smaller than 30k, then you would still get that. All right, so the other way is, this way might be easier if you want to do that way. And so the other way is this. So you are going to prove, so I already know 5k plus 6 is shorter, is younger, is smaller than 6k plus 5. I just need to show this number is smaller than 6 copies of that, which is apparently true. So I would get what I need.
Gotcha.
Okay, so the basic idea is either do something to match the left side or do something to match the right side. That both will work. Either way should work eventually. Sometimes maybe one way is better, easier than the other. You can pick the way you like. Okay. All right, so if I want to match the left side, I add 5. If you want to match the right side, you multiply by 5. But after that, you have to add one more statement. Any other question for number 4? So if not, number 5, let me write down the proof. Well, I guess some of the students still have trouble writing down the proof. So whenever you prove something is a subset of the other, you always start your proof as picking something from the smaller the subset A. In this case, A is the subset, right? So I pick something from the subset. X is the element in A. If you want to use a sentence, you can say, let X be an element. Let X be an element in A, of A. But usually the symbols will be easier, saving you time writing the long sentences. And your last statement should always be, so X is in the superset. So A is called subset. The right side, the bigger one, is called a superset. So the last statement should be X is so. X is in B and intersection with C. If you have this, then you can prove. Look at these two. Combining these two, what does this mean? What's X? It's an element in A, right? So it's like every element in A, every element X in A is also in B intersection with C. So that's exactly the definition of subset. So how do we make the argument? If x is in A, then x will be in the intersection. I would ask you to give explanation for your step. I know some students said, okay, so x is in the intersection, but you do need to explain why. So you will say x is in A since, or you can write backwards. Then x is in B. Why is x in B? We did have many students who just write down x is in B, but please explain why. Can someone explain why x is in B? Look at the condition. Since what? A is a subset of B, right? Although I use the symbols because it's easier, saving time of writing a lot of words. When you read it, you can still use sentences. So then x is in B. Why x is in B? Since A is a subset of B. That's given in the problem. So we can take a look at the problem. It says very clearly, number 5. If A is a subset of B, what is the definition of subset? Because it means every element of A is also an element of B. So look. Okay, and x is also in C. Why? Why is x in C? Because it says C is a element or subset of, A is a subset of C, right? So if you go back and look, it says here, A is a subset of C. So every conclusion, so that's the conclusion I got. That's the conclusion I got. You need to explain where it comes from. So how do you know x is in B? Well, because the problem tells us A is a subset of B. How did you know x is in C? Because the problem tells us A is a subset of C, and that's the definition. And then I can say, I guess, pretty much from here, I left too much space. Pretty much you can go down there. X is in B and C. Where does that come from? If you don't explain this, it should be very obvious. But if you do want to explain, that's by the definition of intersection. What's the definition of intersection? What's the definition of intersection? If x is in B and x is in C, then x is in both of them, which is in B and C, and it's that symbol, intersection symbol. So every step, I have these 3 conclusions. I started with x is in A. That is, you can randomly pick an element from A, right? So that's something you can always do. And I got a conclusion x is in B. Where does it come from? It comes from this condition given. I got a conclusion x is in C. Where does that come from? It comes from the condition A is a subset of C. And then I got x is in intersection. That's the definition. Where does that come from? That's the definition of intersection. So we're proved. This statement is proved. And well, if you want to add one more sentence, statement to say, therefore, you can. But if you don't want to do that, it's obvious. Usually, you can stop right there if you want. If you want to stop there. Or you can add one more sentence to repeat the statement they want you to prove. Okay, questions about this one? Okay, now, number 6.1. Some students made mistakes. So we have 5 symbols. 1, 2, 3, 4, 5. So the first 4 must contain letters from A, not from A to M, must end by digit. So last place has to be a digit. But the first 4 places, they didn't say they have to be letters, right? They didn't say that. So that means you can take digits. For example, you can take a 1, 1, 1, 1, 1. That will work. If you want to take the x 1, that will also work, right? So I think some students misunderstood the problem. So these could be letters plus digits. But the letters cannot be from A to M. So it starts from N to Z. And so the same for the other places. And in this case, if you want to start from the last one or the previous one, for the first question, how many hints are possible? Because there's no restriction about distinct or anything, so you can start with the first one. How many options do I have for the first place? We got 13 letters, right? And 10 digits. So together you should have 23 choices. You can pick any letter from N to Z or any digit from 0 to 9. So some students thought 13 because they thought they have to be letters. They didn't say they have to be letters. They just say the last one has to be digits. The first 4, they could be letters or digits. The same for the second, you can, because they allow repetition. If you use the, say, Z, you can use Z again. If you use the 1, you can use 1 again. So you still have 23 options. And the last one, because it has to be digit, you can only have 0 to 9 to use, which gives you 10 options. All right, so after you multiply, then you will get, so that's why you probably need a calculator to work that out. What's that number? Oh, it's 2798410. So that's the first question, 6-1. When you do the second one, because they want all of the letters and digits to be different. So remember what I said on Monday. That's not to deal with the first place first. You should deal with the special place, digit. First, I'm going to pick a number for this place. You can pick a 0 or 1 or 2 or 3 or all the way to 9. That gives us 10 options. But because you want all of them to be different, if you say you pick the 1 for this place, can we still use 1 here? You can't, right? So you are out of that 1 digit. You only have 9 digits available for this place. For these 4 places, it doesn't matter which one you do first. You can do the first one or the last one or any of them. They don't matter here. And you can also use the letters from N to Z, which gives you 13 options. So together, you only have 22 options left. Okay? Again, some students still did 23, and that won't be right. And once you pick either a digit or a letter, you are out of another one. You use the 1 here, use the 1 there, you only have left with 21 letters and digits, and 20 and 19. So multiply them together, you should get 1755600. Okay. Questions about these 2 problems? So here is pretty much just multiplication rule. For each, so the first step, you pick a letter for the last digit. And then second step, third step, fourth step, fifth step. So you use multiplication rule. Number 7, the first one, we know because the order does not matter. You're choosing 15 students, choose 6 students. You can say I can call Elena first, and then call James, and then call Elsa, can call somebody else. But I can change the order. I can call James first, and then Elena, then Elsa, and somebody else. So it really doesn't matter who you call first. So when you rearrange them, and the order doesn't matter, it's still going to be the same 6 people. So in that case, it's combination. So when you do the combination, there are 2 ways you can do. I'm going to do the quick way, 15 times 14, 13, 12, 11, and 10. 6, 5, 4, 3, 2, and 1. And reduce that, simplify, you should get 5,005. For number 2, some of the students made mistakes in the second one. 15 choose 6. I think Curtis, you made a mistake, and somebody, there were a couple of students. Well, 15 choose 6, you already got the answer here. You don't have to do it again. It looks like when you did the second time, you actually got the wrong answer. So when you
I
do
forgot
number
to divide by 2. That's what it was.
Oh, okay.
Yeah.
So you actually don't have to do that again for the second part. You can just take that answer. What we said last time is, so we want to figure out how many ways without any man, right? So you're going to figure out how many ways, what's the question again? How many can be selected? such that, at least one man, right? So we want to have at least one man, but what we're going to do is we're going to do the opposite, negation, no man at all. So at least one man, the opposite of at least one man is no man. Greater than or equal to 1, the opposite, what you can call negation, is going to be 0. Less than or equal to 0, which means 0. So no man, which means you're going to have 6 equal, means 6 women. How do you get 6 women? You only have 7 women. You choose 6 women. 7 choose 6. So you can work this out. There is a quick way, but we're just going to do the slow way here. 7, 6, 5, 4, 3, and 2. So notice that all of these will cancel. You're going to get 7. Okay, so these 7 ways will not have any men. So we're going to deduct that from 5,005. So we can take the answer from part 1, subtract the 7. That gives us 4998. So 5,005, there are 5,005 ways to choose 6 people, including no man, 1 man, 2 men, 3 men, 5 men, 6 men. But we don't want, we want to have at least 1 man. So we're going to deduct no man. No man, there are 7 ways, no man, or 6 women, right? So you deduct that, that will give you the rest of the. These 4,998 ways will guarantee that contains at least 1 man. Part 3, looks like everybody did the cases, right? So I can show you both ways. So you can do case 1 because it says we have to have, okay, so you can do choose A, no B, or case 2, choose B, no A. Case 3, no A, no B, or neither, right? So no A, no B. So if you want to choose A, you already have 1 member. You only need to select 5 more. So select 5 more members. And because you cannot choose B, so that only leaves you 13 people to select from. We have 15 people, but you already decided you're going to select A. And you decide you're not going to select B. So 2 people are out. 15 minus 2 gives you 13. So because you cannot choose A again, you don't want to choose B. So that's 13 people. And since you already have 1 member, you just need 5 more members. So 13 choose 5. And you can work that out. It would be 1,287. The same thing here. It's still going to be 13 choose 5, 1,287. And no A, no B, which means you don't have any member yet. So that means you got to choose 6 people. And you still have 13 people available, no A, no B. So if you work that out, it's 1,716. And you have to add all of these 3. This time you cannot do multiplication because once you choose 6 people, no B, but A, that's already give you 6 people here, that gives you 6 people here, that gives you 6 people there. So each case will give you, it will finish your job of selecting 6 people. So that's why we add them, not multiply them. So we get 4,290 ways to select 6 people such that A and B don't work together. So that's solution 1. There is another way that you can do, which is quicker. So anybody remember the quick way? I'm going to find how many ways are there to choose 6 people with A and B, right? So choose both A and B. Choose A and B. So if you decide that you're going to choose A, choose B, how many more people do we need to choose? We need 6 people. You already have 2. So 4 more, right? So choose 4 more people. And we still have 13 that you can choose from because you cannot choose A again, B again. So you would do 13 choose 4. That gives you 13 times 12 times 11 times 10, 4, 3, 2, 1. So let's reduce that. So that gives us a 13 times 55. So that's 715 ways. So these 715 ways will contain A and B. which is the case we don't want, right? So that's why we deduct that from that 5,005. The answer we got from part 1, which is still give you 4,290. So this might be a little quicker. Instead of doing 3 cases, you just have to do 1 case and do a subtraction. Okay, so that would be solution 2. Any question? The next one, okay, so the binomial formula, plug into the formula. It seems like everybody plugged in the formula right, but when you do the calculation, be careful. 1 or 2 of the students made mistakes. So how do we work this out? You're going to distribute that 4 to both of them. So you're going to get a 2 to the 4th times x to the 2 times 4, 8th. So that will give you 16x8. Okay, so be careful. I think some of you forgot to distribute the 4th power to raise 2 to the 4th, because everything in the parentheses, you have to raise it to the 4th. So I'm just going to write down the correct answer for you. So if you didn't get this right, correct it. Wait, hold on. All right? Yeah, okay. All right, so this is number 8. Okay. We crossed out number 9. Number 10, the first one, everybody got it right. The second one, I do want you to explain. I didn't put it there, but when I take an exam, you should, when you determine something, you should explain why this is reflexive, why this is not symmetric. So for number 10, by the way, I guess for the first one, if you don't explain, that's fine. It's 5p25, which means does 5 divide 25? If you just put yes, that's fine, because this is really easy. The second one, you can put a no. It's 2 does not divide 27. The third one, 8 does divide 8. You put yes. But when you do second part, okay, let's just 45 questions. Please explain why. I mean, I think only 1 or 2 students explain. I know James, you did explain. There's another student did explain something, but don't just put yes, reflexive. No, not transitive. Not symmetric and not transitive. You do have to yes, transitive. So reflexive, you say yes, it is reflexive. So when you take the exam, I will add a sentence there to say justify your answer or explain why. So you do have to explain why is this one reflexive. How do we explain that? Yes, because x always divides x for any x, right? For any real number x. I think x is a real number. Actually, integer. So for any integer x. Look at the question. What it says is, it says, define a binary relation P on Z. Z means integer set. So the numbers we're discussing are just going to be integers. So when you discuss here, for first property reflexive, you will have to say, why is this reflexive? Because any integer x will divide x. Now second one, it's not symmetric. Why not? If it does not satisfy property, it's very easy to explain, because you can just give one counterexample. Say, okay, 2 divides 4, but 4 does not divide 2. Right? That's obvious, because what's symmetric property? When you switch them, it should still be true. That relation, in this case, it's dividing relation, should still hold. 2 divides 4, you should still have 4 divide 2, but apparently 4 does not divide 2. So that's why it's not symmetric. You cannot switch them. After you switch them, it does not satisfy that dividing relation anymore. This third one, it is transitive. Explain why. Because if x divides y and y divides z, then x will divide z, right? I mean, you can prove it. I think for this one, if you didn't prove, as long as you write this down, it will be good. If you didn't prove, that's fine. And we should know how to prove this because that's divisibility we learned before. X divides y means y equals x times z. That's y equals x times, an integer k. And y divides z means z equals y times integer l. So after you plug y into z, you will get z equals, replace this y right here with xk, x times k times l. So what does this mean? It means x divides z, right? It can be proved very easily. So if you don't want to show the proof, this is fine. You can just say, if the first number divides the second divides the third, the first has to divide the third. Okay, so that's the explanation that you have to give. Questions? Number 11 is the same thing. Number 11 is a little easier because since they already said, they told us that it's going to be reflexive, symmetric, transitive. So all you have to say, it's going to be the same thing here. But in number 10, because the relation defined is a dividing relation. If the first number divides the second, then we say they're related. In number 11, it's not the same. The first divides the second. The relation defined is that if you take a look at the question, if the first number squared x, second equals the second number y squared. So this, if you don't like the letters x and y, use first number and second number. So this is how we define. If the first number squared equals the second number squared, you say first number relates to the second. So we are going to write down the three properties. Why it's reflexive? Because reflexive, you are checking the first number is x, the second number is also x, because x squared equals x squared. Obviously, it's true for any, in this case, real number. So for any real number, x. And the reason I know it's real number because it says here, for all real numbers, x and y, right? So that's this time we're discussing real numbers. Now, second one, it's symmetric. What's the explanation? Because if x, the first number squared equals the second number squared, then we can guarantee y squared must be equal to x squared for any x and y, any real number x and y. So when you switch them, it's still true. The third one, it's transitive. We're talking about transitive property, it's talking about three numbers. Because if first number x squared is equal to the second number y squared, and the second number y squared equals the third number z squared, we can guarantee the first number x squared must be equal to the third number z squared for any real number x, y, z. That's also, you don't really have to prove this. It's obviously true. Okay, so that's the explanation. So you just have to plug in all the relations, whatever the relation is. Either it's a square relation or dividing relation. You have to explain that this way. The last one, number 12. So, there is a relation defined. What is the relation? The first number's absolute value equals the second number's absolute value. So how do we divide those numbers we have? So we have 0, plus or minus 1, plus or minus 2, plus or minus 3. We are given 7 numbers. You want to divide those numbers into different categories such that the number from the same category are equivalent to each other or are related to each other. So this is how we use to define they're related. So, well, you can start with any number. So normally we start with the first number in the list. But if you say, can I start with 3? Yes. Can I start with negative 3? That's fine. And you can start with any number. So I'm going to start with 0. I'm going to try to say, so my first number is 0. So I can try to figure out the absolute value of 0 is equal to second number. Can I find another number also has the same absolute value of 0? No, right? So I can't find anything else related to 0. So 0 will be by itself. So 0 is already found a category for 0. Now we're moving on to the next number. So I'm going to pick positive 1 and try to find out what number is equivalent to positive 1, relate to positive 1. So it's like, okay, what number has the same absolute value as 1? Well, apparently negative 1 has the same absolute value. So we're going to put them together. And you cannot find anything else except negative 1. So similarly, if you already put them in the category, mark them out so you won't do them again. And the same for 2 and negative 2. The same for 3 and negative 3. Okay. You may not always get like the opposites in the same thing. Like previously, the example that I gave you, I can give you the same number to do another example. So if I give you 0, last time I wasn't able to finish. So if I change the relation, which numbers are in the same class depends on how the relation is defined. So on the previous example, I have absolute value relation. I can change that to this. The first number, if the first number minus the second is divisible by 3. But usually when I give the question, I won't say first and second. I would say x and y or the m and n, right? But you can change them to first and second. Maybe it will help you. So still, I'm going to start with the 0. Okay, I need to figure out, so this will be my first number, 0. 0 minus which number will be divisible by 3? So if you cannot see it, check every number. Does 3 divide 0 minus 1? No. Does 3 divide 0 minus negative 1? No. So neither 1 or negative 1 will be in the same class as 0. Now, does 3 divide 0 minus 2? No. Does 3 divide 0 minus negative 2? No. So this is the number I try to figure out. And I will plug in every single one. And none of them works, so except 3. But if I put a 3 here, 3 does divide 0 minus 3. And 3 does divide 0 minus negative 3. So that's why we have all these 3 in the same class now. Okay, so since I did this and that, I marked them out. So I'm going to start with whatever left. I'm going to pick 1 to figure out 1 will be with which class. Would be in the same class with which numbers. So I put this is how I start. The first number is 1. So 1 minus negative 1 will give me a 2. Well, 3 doesn't divide 2, so negative 1 will not be in there. 1 minus 2 will give me negative 1. Again, 3 doesn't divide negative 1. But if I plug in negative 2, 1 minus negative 2 is positive 3. 3 doesn't divide positive 3. So 1 and negative 2 should be in the same class. So I did 1, I did a negative 2. They're out. The only 2 numbers left is negative 1 and positive 1. So let's check. Negative 1 minus 2 is equal to negative 3. And 3 does divide negative 3. So that's why I put them in the same class. And after that, we're done. Every number belongs to a class. So we only found 3 classes. And that's all. So make sure you include every number. You're not missing anything. And you're not going to have any number in the 2 different classes twice. So that's the special property about equivalence class. Only equivalence class will have this property. Every number will belong into one of the classes and won't appear in 2 different classes. Okay. All right. So that would be the answer for that one. I'll give you another example because in case you have trouble. Okay. So. Yes, any questions for the final practice?
Yeah, I have a question on 6-2. So you explained how for the digits you had to go down, so we started with the 10 in the 5th place,
Yeah.
and then you start back at the beginning and go 13 letters, 9 digits. So since they're both distinct, would then the second place, would that be 12 letters and 8 digits? Or would we keep it at 13 letters?
In this case, you will look at the digits and the letters together, combine them. So we have the letters available is from N to Z, which has a total of 13 letters, right? And digits is from 0 to 9. We have a total of 10 digits. So together, we have what? How many?
20.
Choices. Let's just call them symbols. Whatever, if it's either a letter or digit, it's a symbol. So we have 23 symbols we can choose from. And so what, like last time I did explain, you should not start with the other 4 places. You should always start with the last one, because if I try to figure out how many are from here, there will be different, because you could pick a letter or a symbol. That will give you different choices for the last place. So you say if I pick a 1 here, then I cannot use 1 here, right? And,
Right.
But if I did not pick I may pick a 1, 1, 1, 1. I'm sorry, 1, 2, 3, 4. Then I have what? 6 options left, right? But what if I picked the 1, 2, 3, Z? I have 7 options left. If I picked maybe 1, 2, Y, Z, then I have 8 options left. If I picked something else. So if you try to do these first, you won't be able to determine how many options are there. It will be
Right.
different.
I understand that the 10 starts there first, but the letters
Okay.
is what I'm confused on.
Okay, so we start with the last one, because the last one has to be digits. So that gives us what? How many
10.
digits? 10, right? So after you use one of the digits, how many symbols do you have left?
22.
Yes, 22 digits, right? So you can do any of them. Say let's determine how many symbols do I have for this place. It would be 22, right? Because
So then
you
Sorry.
You
so then
are-
the next
go ahead. I'm sorry. Go ahead.
Sorry. So the next one, would it be also to add 13 letters plus 8 digits?
Yes.
Oh.
Wait, hold on.
But-
Not letters. Okay. Don't do that. Don't separate them, because you
Oh.
won't know whether you pick a
Oh.
letter here or what digit, right?
Okay. Right.
So I would just say, okay, since I used a digit here, and then I used another either digit or letter, right? Doesn't matter.
Okay.
I'm going to have -2 there. It only gives me 21 options, either
Okay.
letters or digits. So
Yeah.
but
That
don't
makes
do them
sense.
separately. Okay. The same for the next and the next. Okay.
Got it. Thank you. That
All right.
helps.
You're welcome. Any other question? Okay, all right. If not, so that will be all for today. And so our exam will be next Wednesday. Okay?
I do
We
have a
will
question.
Yeah.
I was going to say, so the past 2 tests that we've taken, the study guide has been very similar to the questions that are being asked, which has been super helpful, and thank you. Is it, even though I know that this is like technically considered cumulative, are we going to have questions from like the first exam really, or is it just going to be pretty much what the study guide's looking like?
It's going to be similar to the study guide.
Okay, cool. That's all I needed to know.
Okay.
Thank you.
Thank you.
All right. All right. So I guess I'll see you on Wednesday.
Yeah.
They put a small heater.
Yeah, they're really cool.
Is your shuttle one too?
Oh, so his office is
Did they say that they were going to?
Is this Curtis or anyone else? Is this the binomial?
Your meeting has ended.